Welcome back to the course, everyone. In the previous section, we used the Anaconda prompt to create a new LangChain environment. As emphasized, it's recommended that individual projects be run in separate environments to prevent package conflicts or the accidental removal of important documents. They also offer the flexibility to install different Python versions and maintain unique package sets in each, without the risk of interfering with the base setup. We also registered this environment as a Jupyter kernel so that we could use it in our Jupyter notebooks. Finally, we set our OpenAI API key as an environment variable, allowing us to utilize OpenAI's models and API. I'm now happy to welcome you to this lesson where we'll create our first chatbot. We'll be relying on Python and OpenAI's API. Note that we won't be making use of the LangChain framework just yet. This section introduces you to creating chatbots with OpenAI's API and familiarizes you with its main components. Since OpenAI's integration in LangChain relies heavily on this API, having a general idea of how it works is valuable. With that said, let's get to coding. Open a fresh Jupyter notebook. Load the .env extension and then apply the .env magic command to set your OpenAI API key as an environment variable. Next, we should configure the OpenAI library to recognize our key. To do so, import the OS and OpenAI libraries. Then set up OpenAI.API key to equal os.getEnv. Pass the name of the environment variable as an argument. It's as easy as that. We're now ready to experiment with OpenAI's models. We'll do so by implementing a helpful chatbot that answers users' questions. But we'll also give it a sarcastic twist. First, create an OpenAI client by utilizing OpenAI's class of the same name. Then define a completion variable that will serve as our chatbot object. Set it equal to client.chat.completions.create. The first parameter that the create function requires is the model. I'll opt for GPT-4, but you can experiment with any OpenAI chat model. Just visit their website, pick a language model of your choice, and write the respective name as a string. Keep in mind our discussion about costs, especially if you plan on working on your own projects. Make sure you opt for a cost-sensitive variant. The second required parameter, messages, contains the messages we'll give the model before starting the conversation. These messages will be a way to instruct the model on how to behave. It expects a list of dictionaries, each containing 2 required key-value pairs. The key to the first pair is role, which can be mapped to one of the following values: system, user, assistant, and tool. We'll work with tools later in the course. For now, let's focus on the first 3. The key to the second pair is content, which stores strings with questions, instructions, and other helpful content that will guide the model towards responding suitably. All right, after a short break, we'll discuss the difference between system, user, and assistant roles. Catch you in a bit. Hey everyone! Last time, we started creating our chat completion object. We left it off at the messages parameter, a list of dictionaries where we can specify prompts as a system, a user, or an assistant. Let's now discuss each of these roles individually. The system role is typically used for directing the model. It defines the model's purpose, persona, output format, and any other necessary instructions. Providing the bot with a system message guarantees a better response for your specific use case. For instance, if you were to create a grammar corrector, an appropriate system message would be, "You will be provided with statements, and your task is to convert them to standard English." If you were to create a chatbot with a sarcastic twist instead, you could give it the following instructions. You are Marv, a chatbot that reluctantly answers questions with sarcastic responses. For more ideas on possible system prompts, refer to OpenAI's webpage. The second role on our list is the user role. This is you. The content you pass as a user can range from a question you need answered, to a sentence you want extended, to a paragraph requiring grammar corrections, and much more. The third type of message we can include in our prompt to the model is an assistant message. Assistant messages can be used whenever we want to provide the model with example outputs to give additional context or guide it toward the writing style. As an example, imagine we train a chatbot to perform sentiment analysis. So, we pass the following sequence of system, user, and assistant messages. First comes a system message reading, "You will be provided with a tweet, and your task is to classify its sentiment as positive, neutral, or negative." Then we feed a user message with the following content. "This new movie is extraordinary." An assistant message then helps the model identify that as a positive tweet. We follow up with a second example reading, "This new album is all right." An assistant message then notes that this tweet has a neutral tone. Let's now give an example of a negative tweet. I've chosen the following. "This new book could not have been written worse." As usual, an assistant message then describes the sentiment, which, in this case, is negative. The model should now have understood its purpose and the way in which it must answer. Imagine we now passed the following user message. "This new song blew my mind." Had we not provided the system message or these couple of examples, the response to that message would likely have been something as follows. "That's great to hear. Music has such a powerful impact. What's the song, and what did you find most striking about it?" But we would expect our instructed chatbot to respond with positive. As a final remark, note that the model's response is also considered an assistant role message. In the next lesson, we'll see this explicitly in the code. All right, I'm confident you've grasped the idea behind each role type, which will prove crucial in our LangChain discussion shortly. Now it's time to return to our notebook and continue implementing our chatbot. See you in a bit. Welcome back, everyone. In this lesson, we'll resume the implementation of our chat completion in Jupyter Notebook. We'll start by instructing the chatbot to answer questions sarcastically through a system message, and then pass our question as a user role message. Let's get into it. The first dictionary in our messages list should map the role keyword to system, implying a system message. In addition, set the content to the one already familiar to you. You are Marv, a chatbot that reluctantly answers questions with sarcastic responses. In the second dictionary in the list, we'll create a user message. I'll go with the following request. I've recently adopted a dog. Could you suggest some dog names? Run the cell and inspect the completion variable. We find that completion is an instance of the chat completion class, with the parameter choices storing a list of choice objects that, in turn, keep the responses from the chatbot. By default, the model returns only one response, which is typically the desired setting. This number can be controlled through a parameter called n. Of course, more responses results in higher token consumption, and therefore higher cost. Okay, the role assigned to this message is assistant. Additionally, information is available on the number of completion, prompt, and total tokens. Finally, for this lesson, let's check out how the chatbot responded by displaying the output in a more readable form. To do that, first retrieve the choices list from the chat completion object, then select the first and only item in the list, fetch the messages parameter from the choice object, and lastly, extract the content from the chat completion message object. Make sure you apply the print function to the string to ensure the message is nicely formatted. And here is our sarcastic response. Ah, typical Marv. Excellent job, everyone. As homework, implement the tweet classifier from the last lesson's example, which classified comments as positive, negative, or neutral. If you hit a wall in the process, refer to OpenAI's examples page and get a sneak peek at the solution. In the upcoming lesson, we'll discuss additional parameters that can help further control the model's response. See you in a bit. Welcome back. In this section, we've discussed the roles we can employ when passing a message to a model, a system, user, or assistant role. We then used a system message to create a chatbot that adopts a sarcastic persona. In this lesson, we'll discuss a few more parameters that can affect the model's response: its maximum number of completion tokens, level of randomness, and the option to stream it. Let's begin with the tokens. As discussed earlier, OpenAI sets its model prices based on the number of input tokens, the ones we feed to the model, and the number of completion tokens, those the model generates. Both are capped to prevent users from inputting an excessive number of tokens and to stop the models from generating endless text. Still, it's essential to have additional control over the amount of text generated. Models often tend to be wordy and provide more information than needed. This can pose a problem in the long run since we pay for the tokens the model outputs. As a side note, this pricing only applies when using OpenAI's models through the API. In contrast, the ChatGPT platform is subscription-based rather than token-based, and you don't need to worry about the model generating long texts. All right, it's time we see the token parameter in action. Open last lesson's notebook. When defining the completion variable, keep the system message the same, but let's test the model with a different user message. For example, could you explain briefly what a black hole is? Define the maximum tokens parameter and assign it a limit of 250. Run the cell and print out the content. As always, our sarcastic chatbot gives an excellent response. Let's now see how it performs when we narrow the cap down to 50 tokens. This time we get a much shorter, even incomplete, response. So we need to be careful not to limit the model too much. I'll now revert to 250. Okay, what's next? Another parameter we'll use throughout the course is temperature. It accepts values from 0 to 2, where higher values increase response randomness. Although it defaults to 1, let's explore its behavior at the extremes. Set the model's temperature to 0 and remove the sarcastic condition to create more of an educative rather than a sarcastic bot. Let's again ask it to explain what black holes are. We obtain the following informative response. Let's now generate a new chat completion. Comparing the two answers, we find the new response similar to the previous one. Of course, the wording is slightly different in places due to the unpredictable nature of these models, but overall, the two generations are quite alike. Models with lower temperatures can be used when creating a chatbot for educational purposes, because the answers must be more academic and informative rather than creative. Okay, let's now increase the temperature to maximum and study these results. Well, we can all agree that this is far from helpful. The bot deviates from the topic very fast, and not long after, it starts generating meaningless text. So, such large temperature values are rarely helpful. I'll switch back to a value of 0. Another parameter that controls determinism is seed, like the seeds we fed to machine learning algorithms for reproducibility. When dealing with LLMs, determinism is not guaranteed, but the outcomes will be as similar as possible. You can experiment with this parameter at home. From now on, I'll set the temperature parameter to 0 and the seed to 365. I suggest you do the same to obtain results like mine. Okay, moving on. One way to make a chatbot more responsive and user-friendly is to print out the output continuously, rather than displaying it only after it's fully generated. The stream parameter allows us to achieve precisely that. All we need to do is add it to the list of parameters and set its value to true. Running the current cell and the following one, we find our variable is no longer a chat completion, but a stream object. What's important to know about it is that it can be iterated with a simple for loop, like so. Let's print the iterator in the body of the loop. Executing the cell, we find a long list of chat completion chunks objects. As their name suggests, they contain only a small chunk of the message. Now, within the for loop, let's try to print only the content of each chunk. First, access the choices parameter, extract its first element, then access the delta parameter, and finally, retrieve its content. To print the chunks on the same line, add an end parameter and set it equal to an empty string. Redefine the completion object and run the for loop. Look at that! We've managed to stream our text on the screen. How cool is that? This marks the end of our short introduction to the OpenAI API. I'm convinced you now find creating a chatbot with APIs much more fun and rewarding than merely chatting with ChatGPT. It gives you much more control over the responses and allows you to create some exciting chatbots. But wait until you see what LangChain has to offer. In the following sections, we'll employ intriguing projects using OpenAI's models and the LangChain framework. Until then,